Test for question 52 and 53. The circuit shows that the switch S is in position 1 for a long time and now it is moved to position 2. Zener diodes are ideal, and what will be the voltage at inverting terminal V negative when the output is at 5 volt and switch has just moved to position 2. So now let us find out this condition. When switch is at position 1, the capacitor will be charged to plus 30 volt and V negative will be very much positive, and hence V negative will be greater than V positive, so the V output will be minus 5 volt because of the Zener diodes. So the voltage at this point Vx, so the Vx will be minus 2.5 volt because of the voltage divider, and hence V positive will be minus 2.5 volt at the non-inverting terminal. Now to switch the output to plus 5 volt, V negative should be less than V positive. Inverting terminal should be less than non-inverting terminal. For that, if we switch to position 2 of the switch, the capacitor will start discharging and it will start charging towards the negative voltage. Hence, when V negative reaches minus 2.5 voltage, at that time there is a chance that it will go below V plus, that is non-inverting terminal, and the output will switch to plus 5 volt, and then Vx, the voltage divider will be at 2.5 volt. Hence V plus, that is non-inverting terminal, will be 2.5 volt. Hence whenever V negative is just below V positive, this sequence of events happen and V non-inverting reaches 2.5 volt. So it will be well below 2.5 volt to ensure that V output will remain at 5 volt. Hence when we move to position 2 and output is 5 volt, V negative is minus 2.5 volt. So the answer for question number 52 is A. Now for question number 53. So question 53 means the time delay between the switch moving to position 2 and V output switching from minus 5 to plus 5 is what? So that depends only on discharge of this capacitor. Now let me calculate V minus. V minus is voltage across this capacitor, or whenever this resistor is connected to switch 2, it is voltage across resistor, that is IR, and minus 15. Now we don't know I. So I is, if capacitor current is IC, then capacitor current, if it is IC, then I will be minus of IC, that is minus C dV by dt, minus C d by dt of voltage across capacitor is VC e raised to minus t by RC. So it is minus C VC minus 1 by RC e raised to minus t by RC. So it is VC by R e raised to minus t by RC. That means V negative is Vc into e raised to minus t by Rc minus 15. Now we know the value of R is 10 kilo ohm, C is 1 microfarad, and V negative is minus 2.5 volt. If you substitute all these values into this equation, you can get T is equal to 8.75 millisecond. So the answer is B. Thank you. Test 4, question number 54 and 55. Acceptor and donor density is given. Intrinsic density is given. Reverse bias is applied 5 volt. So we are supposed to find the width of the depletion region and capacitance offered by the depletion region. Now we should remember that it is reverse biased. So we are not supposed to find the depletion region width at 0 voltage or when there is no voltage applied, but we are supposed to find the width of the depletion region when 5 volt is applied as reverse bias. Now let us find out the answers. Now we should remember a few formula. One is V0 is KT into natural logarithm ND NA upon NI square volt. That is a cut-in voltage. So we can find out this by KT is 26 millivolt and ND, NA and NI is given. So this becomes 0.633 volt. If you substitute all the values, you get this. Then width of the depletion region W is root of 2 epsilon V upon Q into 1 upon NA plus 1 upon ND. Here V is V0 plus reverse bias voltage 5 at this time, and epsilon is 8.85 in 10 raised to minus 14. So if you substitute all these values, you get 2.83 micrometer. This is the width of the depletion region. So this is answer number C. Now for question 54, question number 55, capacitance. Capacitance is epsilon A by D. Now we have epsilon 8.85, area is given 400 micrometer, and width is the distance. So from this equation we get 14.6 into 10 raised to minus 15 farad. That is answer A. Thank you.